would be over 3 on the positive side of your graph, and down 7 because it's -7. That's your center, and then you would go out on all sides by 5.
So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. That's your center. So 2, 4, 5 is 1 point. 1, 2, 3, 4, 5. Another point 3, 4, 5. 1, 2, 3, 4, 5. Please say that this is a circle. Thank you. I know it's not.
Jeremy said called it an egg yesterday.
Yeah, he said it was an egg. Okay. Do we know how to graph a quadratic function? Do we need to review how to cut? The problem will ask you to graph showing the shape, the vertex, the x and y intercepts. Yes? Okay. So let's choose a problem. So let's say f of x equals, let's say negative x squared minus 4x minus 4. Is this a quadratic function? Does it have a min or a max? Yes. Always remember from transformations, we graphed x squared like this. How do we graph negative x squared? Right. Always connect to the topics we looked at. I'm trying to do that all the time for you. Okay, so number 1, the shape obviously is a maximum. Number 2, I need to find the vertex. And I need to remember how to find the x-coordinate of the vertex. And then I'm in business. Because then I will be able to find the y. It's perfect. Joseph and I are torturing each other in some way or another. Yes, yes. Minus. I'm kidding, of course. You already know me. So 2 times a is -2. Careful, I see 3 negatives. The sign would be?
Negative.
Perfect. How do I find the y coordinate of this vertex? Yes. So f of -2. Negative, careful, very careful. -2 squared minus 4 times -2 and minus 4. So be careful how you plug this in. By the order of operations, I have to do what first? Yes. So -2 squared is,
4.
so f of -2 is -4 because this is +4 with minus in front will be -4. Now I multiply these two and I get,
Positive 8.
and then -4. Ah, 0. What does this mean? Let's think for a moment.
So near.
Exactly. Should I waste my time to try to find x-intercepts? No, this is it. So the vertex and the x-intercepts are at the same point. So in number 3, x-intercepts, -2, 0. Number 4, y-intercept. How do I find the y-intercept? I plug in. Exactly. Thank you. So it's -4. 0, -4. 5, 6, and 7, as we know, they're just words. Number 5, axis of symmetry. X equals -2. Very good. Thank you, Marcus. Maximum, because it has a maximum. Maximum value is
0.
awesome. And then range. See how much you learned? You already have this graph in your mind. You know the range without even graphing it. Careful.
Negative infinity to
-infinity
negative.
to 0. Good. That's okay. I plot the vertex first. I graph the axis of symmetry, not as a solid line. It's not part of the graph. And all I have is 0, -4. 1, 2, 3, 4. And here's what I do because it will help me. 2 units away on this, I measure equal distance to have an extra point on the other side. And here's the graph. So this is f of x, -x² minus 4x minus 4. Any questions? What I would like to show is another inequality, either polynomial or rational, and graph a rational function with you. And then we can stop. So let's look at, let's say, f of x equals 4x minus 1 over x plus 1. What type of function is this? Perfect. What type of the rational function now? 1, 2, or 3? 1. Same degree over same degree, which means the horizontal asymptote must be for type 2. For type 2 is 0. For type 1 is leading coefficient over the leading coefficient. What is the leading coefficient at the top?
4.
What is the leading coefficient at the bottom? 1. So y equals 4 horizontal asymptote. Domain. Leading coefficient over the leading coefficient. That's the method for type 1.
The other end should be 1.
So if the leading if it's 4 over 1, the horizontal asymptote is 4, and the end behavior is 4. Mandatory. That's why it's a horizontal asymptote, because the end behavior is 4. Otherwise, it will not be, right? It will be something else. But if the end behavior is 4, it means that the horizontal asymptote must be 4. They go together. Good. Domain. Yes. Negative. Awesome. He's on the roll today. So you should take the test at 7 o'clock in the morning. Okay, got it. So then what is x equals -1? The function doesn't exist there, so it must have a vertical. It will be a whole if I can remove that factor, but I cannot remove the factor of x plus 1 with any other factor of x plus 1 from the top. Only if it goes away, but it doesn't go away. So it has to be a vertical asymptote. Therefore, I know this for sure. What I don't know is the sign. I'm going to use something close from the left and something close from the right. So let's use something close from the left. -1.1, the top is negative. What about the denominator? With exactly. So what is the sign here then?
Negative.
Careful.
Oh, positive.
Good. So with the -0.9, the top is still negative. But what about the bottom? With -0.9 plus 1. Good. Negative over positive is? Let's plug in 0. Perfect. And let's also find the x-intercepts. When is a fraction 0? Only when the top is 0. It's undefined when the bottom is 0. So 4x minus 1 equals 0, x equals 1/4. I don't want you to use more than 3 minutes on this problem. Okay, 4, just for you. Okay, so let's take a look. So here's this function. It's coming from from 4, going to positive infinity on the left-hand side of the asymptote, correct? 4 to infinity. 4 to infinity. That's clear. Let's see on the other side. It's coming from negative infinity. It's crossing the y-axis. It's crossing the x-axis, going to 4. One more time. From 4 to infinity. On the other side, from negative infinity, it's crossing the y-axis, it's crossing the x-axis, and going to 4. Let's attempt the graph. First, we graph asymptotes, always. 4. And negative 1. Again on the right-hand side. From 4 to infinity. Nice. 0, negative 1 is here. Oh, that doesn't matter. So 1/4, kind of here. From negative infinity, crossing the y-axis, crossing the x-axis, approaching 4. From negative infinity, crossing the y-axis, crossing the x-axis, approaching 4. And this is the function f of x, 4x minus 1 over x plus 1. Can anyone give us the range of this function? We have to look at the graph in order to identify the range. It's not like this is a way more sophisticated function. We cannot think in terms of quadratic. Oh, okay, the vertex is at 0. It must have the range negative infinity to 0. No. I'm sorry. I'm sorry. I forgot to turn off my phone. Gail, I'm in class. I'm so sorry. I'll call you back.
Okay.
Sorry. So what is the range? Yes, awesome. Negative infinity to 4, union 4 to infinity.
And you wouldn't access to find the domain.
You have to find the domain. Without finding a domain, you cannot start the table. There was the first question, second question we asked. X cannot be negative 1, otherwise I cannot identify this, which is the vertical asymptote. So the domain is the starting point for all functions. Absolutely.
So the domain is minus infinity to infinity, correct?
Negative infinity to negative 1, union negative 1 to infinity. That's why I have this here. As you see, the function is not defined at negative 1. These functions are way more sophisticated. They have, yeah. Yes, Brian?
We expect all 3 types on the test.
You mean the quadratic and in some form or another? Yes.
So I meant the 3 types of the.
Oh, no. Rational functions?
Yeah.
No, not the 3. Not type 3. No. No, it's beyond the scope of this course. And I would like to look at the inequality now. So let's say a negative x plus 1 over x minus 3. Do you want it less than? Do you want it greater than? It doesn't matter. The procedure is the same regardless. The inequality, you want it less than or greater than?
Greater.
Okay. Good. How many factors we see?
3.
Very good. Awesome. Negative x is the first factor, x plus 1 is the next factor, x minus 3, and negative x, x plus 1 over x minus 3. X is the variable in the problem. Now on the side, before we start the table, what is the 0 of the factor negative x? When is this factor 0? When x is? When is this factor 0? When x is? And when is this factor 0? Good. I want these three numbers in ascending order in the table. Which one is first? Now I need to put a 0 in each row where it belongs. So for negative x, where will I put it? Under?
0,
Of course. For x plus 1, where will I put it?
-1,
And for x minus 3?
3.
Good. Now something has to be written under each number for the ratio. Remember, this is not a polynomial. This is one of those types of functions or expressions with problems. Where is the problem of this expression? Under what? Say it again. Yes. Where is the problem of this expression? This expression has only one problem. When x is?
It's not plus 0, minus 3.
Ex-
Plus 3 plus.
Exactly. That is the only problem that this expression has. Under 3, indeed. So then what happens when x is -1? It's not a problem.
0,
Exactly, because the numerator is 0. What happens under 0? It's not a problem, because the numerator is 0. So now I need the sign of these three expressions. You either think in terms of end behavior for a linear function, negative to positive, or positive to negative, or plug in numbers, whatever you want. Just tell me the sign of this expression between -infinity and 0.
negative,
Careful. It's the negative leading coefficient. It must look like this.
so positive.
Yes. Or plug in a number. Let's say we plug in -10. What type of number we get? Yes. These two have this end behavior. Is that clear? Positive slope. So they both, without thinking, you can fill it in. So the only one that has a negative leading coefficient will look positive to negative. All the other ones with positive leading coefficient will look negative to positive. Okay. So then on the first subinterval, I count 2 negatives.
Why not, in the case of minus 3, x minus 3, why do we have the second one?
So plug in -10. -10 minus 3 is negative. Plug in 10. 10 minus 3 is positive. Okay? On the first subinterval, I count 2 negatives.
-10? If I plug in -10 for x,
-10 minus 3 is -13. When you plug in 10, 10 minus 3 is 7. They're all the same, right? Just think in terms of the end behavior. When you graph a linear function with a positive slope, it comes from negative, crosses the x-axis, has a 0, and then goes positive, right? If it's a negative leading coefficient, it has to come from positive values because it's decreasing, right? Crosses the x-axis and then becomes negative. Good. So 2 negatives multiplied or divided, it doesn't matter.
Negative, positive.
Good. Now, this tells me what to choose. Do I choose positive or do I choose negative? I choose positive. Meaning I have to choose this and this. It says choose x there if you want positive. If you choose outside, it will be negative. So then I have x in the interval, negative infinity, negative 1, union 0 closed, but 3 open. Can anyone say why is 3 open?
Because
It's undefined. What if I have, for example, an expression like x squared minus 3x less than or equal to 0? It's the same thing, but I have to factor first. And then I apply the table to the same thing.